Okay, I welcome you to week 7 online facilitation. This will be our last major online facilitation. Next week will just be revision and questions and answers. Today, we'll be looking at modern cosmology. Modern cosmology. Okay, in introduction, modern cosmologists base their theories on astronomical observations, physical concepts such as quantum mechanics, and an element of imagination and philosophy. Now, the objectives of this unit: one, at the end, you are expected to be able to explain the Big Bang theory. The Big Bang theory, one of the theories of the origin of the universe. Now, two, you are also expected to be able to explain the steady state theory. And then you are also expected to understand the future of the universe, the future of the universe. So, cosmologists have moved beyond trying to find Earth's place in the universe to explaining the origins, nature, and the fate of the universe. The current standard model of the origin of the universe is called the Big Bang theory. This proposes that a major event, not unlike a huge explosion, set free all the matter and energy in the universe and started its expansion. Okay, so the Big Bang theory actually states that the universe originates from a big and huge explosion whose origin is still not known. Theories of the evolution and fate of the universe go on to describe a universe that has been expanding and cooling since the Big Bang. Early versions of the theory held that the universe will keep expanding forever or eventually collapse back to its initial state. An extremely dense object that contains all of the matter in the universe. Okay. Now, when the Big Bang theory was developed in the mid-20th century, some cosmologists and even geophysicists found the idea of a sudden beginning of the universe philosophically and unacceptable. They proposed the steady state theory, which says that the universe has always looked more or less the same, okay, as it does now, and that it does not change over time. That is what they think. That's what the steady state theory proposes. Now, the steady state theory could not explain the background radiation, though, and essentially all cosmologists have abandoned the steady state theory. Now, let's look at this Big Bang theory in detail. The Big Bang theory describes a hot explosion of energy and matter at the time the universe came into existence. This theory explains why the universe is expanding. Recent versions of the theory also explain why the universe seems so uniform in all directions and at all places. Now, the work of Edwin Hubble Edwin Hubble is the originator of the Hubble expansion. I will invite you to check and Google Hubble expansion. So which showed that the universe is expanding. It led cosmologists to begin tracking the history of the universe. And the dominant idea is that the universe would have been hotter and denser billions of years ago. Okay. Now, they also hypothesized that some radiation that remains from the Big Bang explosion may still be circulating in the universe. Okay. Now, what is the difference between the steady state theory and the Big Bang theory? Let's see what the steady state theory proposes. Now, in the 1940s, British scientists Herman Bundy, Thomas Gould, and Fred Hoyle were philosophically opposed to the requirements that the Big Bang theory put forward for the extreme conditions in the early universe. Now, the Big Bang theory was framed in terms of what they call the cosmological principle, okay? That the universe is homogeneous, the same in all locations, and isotropic, looks the same in all directions in terms of conductivity, resistivity, and all that, and on a large scale. Now, what do you think? What do we think is the future of the universe? A fundamental issue addressed in cosmology is the future of the universe, whether the universe will expand forever or eventually collapse into its initial state. Now, the first case, eternal expansion, is known as an open universe. And the second case, eventual collapse, is known as a closed universe. So please take note of that. The open universe and the closed universe. The closed universe will require sufficiently high density to cause gravity to eventually stop the universe expansion and begin its contraction. Such a collapse will require a deviation from Hubble's law. So observational cosmologists try to observe the distances between very distant galaxies and the Earth using methods other than measurement of redshift. Okay, I also invite you to Google redshift so that you understand what is the measurement of redshift. The scientists can then compare these distance measurements with the galaxy's redshifts to see if the Hubble's law holds or not. Now, in the late 1990s, astronomers compared the redshift of supernovas in distant galaxies. Now, surprisingly, distant supernovas were slightly fainter than it had been expected. Now, this result was tentatively interpreted as an acceleration of the expansion of the universe. That's initially. Astronomers were so surprised by the suggestion that the universe might be accelerating its expansion that they attempted to find other explanation for the relative dimness of distant supernovas, such as absorption by dust. By a few years into the 21st century, however, this other conceivable explanation had been ruled out, and the accelerating universe concept became widely accepted. Now, I'll be giving you another self-assessment exercise under this unit. Now, we are expected to discuss how modern cosmologists base their theories on astronomical observations. Okay, I expect you to do that, to do this. Discuss how modern cosmologists base their theories on astronomical observations. Now, conclusion. This unit focuses on modern cosmology. We learn that modern theories of the evolution and fate of the universe go on to describe a universe that has been expanding and cooling since the Big Bang. Summary. We learned that modern cosmologists base their theories on astronomical observations, physical concepts such as quantum mechanics, and an element of imagination and philosophy. Okay? Now, we also learned that the current standard model of the origin of the universe, called the Big Bang theory, proposes that a major event, not unlike a huge explosion, set free all the matter and energy in the universe and started its expansion. And lastly, thirdly, we have also learned that the steady state theory says that the universe has always looked more or less the same as it does now, and that it does not change over time. Now let's look at Unit 4, that is space law. Space law. International law arises from several sources, chief among them being treaties and custom. Treaties seem an obvious example to the casual observer and can be enacted bilaterally between two nations or multilaterally between several countries, often with the assistance of the United Nations, UN. They are signed formal legal documents. Okay? However, custom was the first player and still an important one in creating international law. Custom is defined as general principles of international law, not embodied in any treaty, but observed and considered binding by civilized nations. Okay? Now, what is the objectives of this unit? At the end of this unit, you, the student, are expected to be able to explain the following space treaties. One of them is rescue agreement. Rescue agreement. 2, moon agreement. 3, registration convention. 4, liability convention. 5, the limited test ban treaty. And 6, outer space treaty. Let me take it again. Rescue agreement, 1. 2, moon agreement. 3, registration convention. 4, liability convention. 5, the limited test ban treaty. And 6, outer space treaty, which is also known as the OST. Now, international law, as far as space is concerned, seems a bit vague and nebulous topic at best, and certainly appears to lack apparent enforcement mechanisms. Unlike violating the civil laws of a nation, there are relatively few expressly defined punishments for violating international law. Economic sanctions and embargoes are largely of symbolic importance, and certainly arresting the offender. Usually, an established nation well equipped with armies and munitions is impossibility. Okay? Thus, nations are faced with unclear guidelines and unforceable punishments that govern their interactions as far as the space is concerned. But yet, more times than not, nations abide by the rules of international law. There are several reasons for this, as well as reasons for breaking them from time to time. One of the reasons is a system of international law is in general interest of all nations. It permits business to transact, travel to take place, and cooperation to ensue in health care areas. 2, cooperation among nations is imperfect because humans are involved. Humans tend to forget what was agreed upon from time to time, but the formality of a treaty helps to solidify what was agreed upon and serves as a base for negotiating good and bad faith disputes that may arise in the future. Okay? 3, nations guard their own interests and will violate international law on occasion. Usually, this is done very selectively, or else the offending nation faces isolation from the rest of the world for crying wolf too many times. Where does space begin? That is the question. Where does space begin? One of the first problems early formulators of space law faced was the definition of where space began. How far up from the Earth's surface did an object have to be located, to be considered in space, and thus subject to the laws for that arena. They considered first the von Karman line, an altitude approximately 53 to 62 miles above the Earth's surface, where aerodynamic lift is largely non-existent. This will be the general boundary of airplane flight and thus airload, and it seems a logical point at which to start the domain of space law. They also considered that below an altitude of 69 miles, sustained orbit is practically impossible. Yet, there are violations of these generalizations. The X-15 classified as an airplane flew at an altitude higher than 62 miles, and satellites have orbited at certain points in the orbit lower than 69 miles. The definition which has evolved is as follows. Any object that is in orbit about a planet is said to be in space. Now, this definition falls under custom and has never been explicitly delineated in any treaty or other official document. Since there is no tangible black letter definition, there is a possibility that the current custom of defining in space may change, defining in space may change in the future to suit the needs of the subsequent generations. Consider the predicament of an aerospace plane, like President Reagan's proposed Orient Express. It will be both an airplane and a spacecraft. So will its passengers be considered astronauts and treated like envoys of mankind? As astronauts are considered under the rescue agreement is highly unlikely. Now, this is just an example of some of the challenges that might lie ahead in defining or choosing not to define clear boundaries for where space begins. Now, let's look at the space treaties one by one. The Limited Test Ban Treaty, perhaps the first treaty to place guidance on the international norms of behavior in space, was the Limited Test Ban Treaty of 1963. Now, the treaty prohibits the explosion of nuclear devices in the oceans, the atmosphere, and outer space. Now, the US, UK, and the Soviet Union signed this treaty. Other nuclear powers such as France and China did not sign the treaty. Now, though on the surface, this treaty may seem to be aimed at slowing down the nuclear arms race, it actually didn't accomplish that at all. As nuclear tests continued extensively underground by the US and the USSR, from a space point of view, though it was extremely critical to ensuring the success of future satellite missions. Nuclear explosions in space propagate radiation and electromagnetic pulses, which can effectively kill all satellites within a distance of the explosion. Previous explosions at high altitudes caused extensive damage to satellites and the electronics on the ground, and created an artificial radiation belt that apparently persisted for years. Now, Outer Space Treaty. This is the treaty on the principles governing the activities of states in the exploration and use of outer space, including the moon and other celestial bodies. It was entered into force on October 10, 1967. The Outer Space Treaty has been ratified by 95 states and signed by 27 others. 2. Liability Convention. Liability Convention. This is the Convention on International Liability for Damage caused by space objects entered into force on September 1, 1972. It has been ratified by 80 states and signed by 26 others. This is a major space law agreement that fleshes out the liability provisions laid out in OST, that's Outer Space Treaty. It applies to both military and civilian space activities. 3. Rescue Agreement. This is the agreement on the rescue of astronauts and return of astronauts and the return of objects launched into outer space, entered into force on December 3rd, 1968. It has been ratified by 85 states and signed by 26 others. This treaty suggests that astronauts are the envoys of mankind and encourages nations to treat them as such. 4. Registration Convention. This convention on registration of objects launched into outer space, entered into force on September 15, 1976. It has been ratified by 40 states and signed by only 4 others. This treaty requires all launching states to keep a registry for objects launched from their territories or under their supervision and report this registry to the United Nations from time to time. 5. Moon Agreement. This is the agreement governing the activities of states on the moon and other celestial bodies. It was entered into force on July 12, 1984. It has been ratified by 9 states and signed by 5 others. The rules against extension of sovereignty to outer space and celestial bodies resolved a good deal of confusion regarding such matters. Now, I'll give you another self-assessment exercise under the space. What do you understand by the term space and where does it begin? What do you understand by the term space and where does it begin? Okay, I expect you to do that. Conclusion. In this unit, we have discussed the various international space laws and treaties. We also looked at space and where it began. Okay, summary. In this unit, we have learned that 1. International space laws arises from treaties and custom. 2. Custom is defined as general principle of international law, not embodied in any treaty, but observed and considered binding by civilized nations. 3. A system of international law is in general interest of all nations. It permits business to transact and travel to take place, and also cooperation to ensue in healthcare areas. Okay. So this will be the end of this online facilitation. By next week, we will look at our revision and also take questions and answers. So wish you all the best and take your studies seriously. Thank you. See you next week.